Welcome back to my channel Shri Statistics. So today we are going to talk about the generalized inverse of a matrix. So when a matrix A is singular, that is the determinant of A is equal to 0, then its inverse cannot be found using the usual methods. So in this case, generalized inverse of a matrix has to be obtained. So, if we have to find out the generalized inverse of a matrix, then it may not necessarily satisfy all the conditions of an inverse, but it will satisfy most of them. So, as it can be seen over here, that it has been mentioned that if there is a set of linear algebraic equations and we have to find its solution, then if there does exist a solution, then it can be found using this method of generalized inverse. So for a generalized inverse, basically a matrix has to be obtained that may serve as the closest thing to an inverse for a singular matrix, that is, as mentioned in the first line, that the determinant will be equal to 0. So if we come over to the definition, then let A be a matrix of order m cross n, that is, it has m rows and n columns. Then a generalized inverse of the matrix A is a matrix G of the order n cross m, which satisfies the condition that A multiplied by G into A is equal to A. This is basically the basic condition for a generalized inverse. So if the determinant of A is not equal to 0, that is, if A is non-singular, and the number of rows is equal to the number of columns, that is, n is equal to m, then the inverse of A satisfies the condition that A into A inverse multiplied by A again will give this A. And basically this can be seen because A into A inverse, like this, will be one identity, and multiplied by A will give A. So that's all from me for today. Thank you for watching.